Hello students. Let's continue our journey through understanding quadrilaterals. In the last session, we discussed the parallelogram and its properties. Today we are going to prove some properties of the parallelogram with logical arguments. In the last section, we saw that the opposite sides are equal. And the opposite angles of a parallelogram are equal. Let's try to prove this mathematically. In parallelogram ABCD, the sides AB parallel to DC and AD parallel to BC. Let's join the diagonal AC. Now, we have two triangles, triangle ABC and triangle CDA. Since AB parallel to DC and AC is a transversal, angle CAB is equal to angle ACD because they are alternate interior angles. Also, AD is parallel to BC and AC is a transversal, so angle ACB is equal to angle DAC. AC is a common site for both triangles. Triangle ABC and triangle CDA. So in triangle ABC and triangle CDA, two pairs of angles and included sides are equal. Therefore, by the ASA congruence rule, triangle ABC is congruent to triangle CDA. Since AB and DC are corresponding sides of these congruent triangles, they are equal. Similarly, AD and BC are the corresponding sides of these congruent triangles. They are also equal. Thus we proved the opposite sides of a parallelogram are of equal length. Observe these congruent triangles again. What can you say about angle ABC and angle ADC? Are they equal? Yes, they are equal. Because they are corresponding angles of the congruent triangles ABC and CDA. If we divide the parallelogram into two triangles through the diagonal BD, we get two triangles, triangle DAB and triangle BCD. We can prove triangle DAB is congruent to triangle BCD, as we did earlier, and hence angle DAB equal to angle BCD. Thus, we can say that the opposite angles of a parallelogram are of equal measure. In the last session, we discussed another interesting property of parallelograms. The diagonals of a parallelogram bisect each other. Let's try to justify this through logical arguments. In parallelogram ABCD, the diagonal AC and BD meet at O. Now let's consider the triangles, triangle AOB and triangle COD. We have seen that the opposite sides of a parallelogram are equal. Therefore, AB is equal to DC. Moreover, angle OAB is equal to angle OCB. and angle OBA is equal to angle ODC. Because they are pairs of alternate interior angles formed by the transversals, AC and BD. Now, in triangle AOB and triangle DOC, two pairs of angles and a pair of sides are equal. By ASA congruence rule, triangle AOB is congruent to triangle COD. So the sides OA and OC are equal. That is, the diagonal AC gets bisected at the point O. Similarly, OB is equal to OD. That is, the diagonal BD gets bisected at O. Thus we proved the diagonals of a parallelogram bisect each other. So today, we discussed the mathematical justification on the properties of a parallelogram, such as the opposite sides of a parallelogram are equal. The opposite angles of a parallelogram are equal. The diagonals of a parallelogram bisect each other. Before winding up today's session, let's have an activity. In a parallelogram, ABCD, angle A and angle B are adjacent angles. We know that the adjacent angles of a parallelogram are supplementary. Justify this statement through logical arguments. Remember, you studied in the previous grade that the angles on the same side of the transversal are supplementary. That's all for now. See you all in the next class.